All right, if we could have everyone find their seats. Just a few of you. Daryl, this means you. I got my eye on people that aren't conforming to the rules. All right, welcome to the Gulf Coast Mass Timber Conference 2. Who here was at the conference last year? Show of hands. All right, a few, not too many. Good, excellent. We've got a lot of new information this year, so even if you were here last year, I think you're going to find this year's conference has some great information, and you're going to see that we've made a lot of strides in mass timber over the past 12 months, and it's very exciting to see what's happening here in Texas. And I'm going to go into a little bit more detail on what the state of mass timber is in Texas later this afternoon. So, with that, I'm going to kick us off. My name is Mark Bartlett. I am the Regional Director for Woodworks. We are a nonprofit organization that provides free design assistance to architects, engineers, general contractors, or developers on anything wood related. But obviously, mass timber has been a very hot topic here lately, and that's what we've been devoting a lot of our time to, is assisting design teams who are tackling their first mass timber project or their fifth mass timber project. So I don't know if I've brought business cards with me. It's been so long since I've traveled. I'm not in the habit of bringing cards. I'll have to check in my bag. If anyone needs a business card, I'll see if I can rustle something up here in my my backpack. So with that, here's our agenda for today. We've got a lot of great presentations and a lot of tours as well. So I will be kicking us off with this little introduction, and then we're going to go into mass timber on the Texas Gulf Coast, where you're going to hear from a lot of the people that are doing the work on the project here at San Jacinto, from the architect, engineer, contractor, and so forth. So we're going to see what they've learned about this project and what they can pass along to you. Then after that, we're going to have a short break, and then we're going to get into what the subcontractors on this project have experienced. For a lot of them, it was probably their first mass timber project as well. And that's what I'm really interested in hearing, is what they've encountered when they've gotten into the nitty-gritty details of the project as far as what they took away from it. Then we're going to have a lunch break. Then after the lunch break, we're going to hear about a really interesting study that's being done on this project for floor vibration. Oftentimes, for the structural engineer, when they're designing mass timber floor panels, what they find is that strength doesn't actually control the design of these floor panels, vibration does. And so obviously, depending on what the occupancy is, especially if it's higher education, you might have lab space where you might have precision equipment. The vibration of the floors could be very important. So this vibration study is going to give us a lot of really great information on how mass timber panels perform. So hopefully future jobs can be even better fine-tuned for their vibration requirements. Then after another short break, we're going to go into the mass timber construction management, and then the IBC 2021 code provisions. That's what I'm going to be talking about. I know when you hear code provisions, don't let your eyelids get droopy. I'm going to keep it interesting, because I think what we're going to see in the next version of the IBC is some really interesting options when it comes to mass timber. We're going to be allowed to go taller than we ever have, and really start to keep up with what's happening over in Europe and in Canada as well. And then lastly, we're going to wrap up with a Texas Woodworks update, where you're going to hear from Kirksey. You're going to hear a project they're doing at Rice, from Aaron Stadelmeyer from Texas A&M Forest Service about the state of our forests, and then from me as far as what's happening in Texas as far as mass timber goes. So I think it's going to be a really interesting day. And I think you're going to find that you're going to take away a lot of great information from this presentation. So a little housekeeping items. Obviously, COVID, social distancing and mask protocols are in place. I see everyone's sort of spaced out pretty good. We got obviously a lot of room in here. So feel free to spread out as much as you want. Restrooms are going to be out the lobby and on either side, men's room, women's room. And then we've got a beverage station, which I have been told that there will be hot beverages that we should be able to take advantage of during the first break. Caterers running a little bit late. Don't shoot the messenger. Hopefully that will be the last of the don't shoot the messenger messages for the day. And then lunch is going to be served at the student center. So we can exit out this door here, or you can exit out the front door, but we're going to head that way. We're going to take a right. We're going to wander down to where like the post office is. There should be signs directing us most of the way. Then we'll go up into the second floor and be able to get lunch. And then after lunch, everyone's just going to doze off, right? The vibration guideline. Where's Joseph over there? He's mad at me. So hopefully we will get a good lunch in us. Now, this presentation is being streamed and recorded. So if you have a question, there's going to be a microphone up here. I assume this is the one that you'll be using to ask a question. So people that are doing it virtually will be able to hear the questions. And then if you don't have or you don't want to stand up and talk, you can submit a question that can be read for you. So feel free to take that option as well if that's what you want. And obviously, if you can silence your cell phones or put them into vibrate mode, that would be great. Hopefully mine's already there, so I don't, if anyone has my cell phone, don't call it right now. Don't call me out. And so we'll get that taken care of so we can go through and have our presentations done. So with that, thank you for joining us today. We hope you have a great day. We want to make sure that this is all possible due to an endowment that was done from the USDA. And if you're investigating a mass timber project and you want to have a little assistance financially, they do these things annually where they come up and you can submit a proposal for some funding for this. And I know a lot of universities, a lot of contractors, a lot of architects have submitted funding for various projects. So San Jacinto was obviously one of these universities that was submitted on this. San Jacinto, I believe, was the only junior college that was included with all these other major universities on this funding. I'd also like to thank the trustees and our vice chancellor who's here today, our trustees, Marie Flickinger, Dan Mims, John Moon, and our vice chancellor, Terry Zamora. So thank you very much for joining us today. I personally would like to thank you because mass timber has been a challenge in Texas. It's not been as well adopted as, say, like the Pacific Northwest. So what we're finding is that when you do one mass timber project, you want to do more of them. So I appreciate you taking the opportunity to reach out and do a mass timber project that we can point to for other locations in Texas and say, look at what we've done already. Let's get on the bandwagon and do some more mass timber. So thank you very much. I appreciate it. So with that, we are going to head into our very first presentation. So I'd like to welcome to the stage our presenters, Chuck Smith from San Jacinto College, Steve Durham from Kirksey, Justin Smith from Walter P. Moore, and Pat Pollard from Tellefson. And if you are in Tour A, then you are going to be leaving right now to go with the Tour A group. So if you can head with Michelle right there with her hand raised, and she's going to take you through the job site. And if you've never been to a mass timber job site before, try and wipe the smile off your face because it's just a really cool experience to see mass timber. We're not going to start till 8:30. Did I not take 15 minutes? 4 minutes, really? I gotta stand up here and do 4 minutes of stand up. All right, let me tell you a little bit about myself. I am based in Dallas, but I cover all of Texas. And yesterday, I got shot number 2 of the vaccine. So if for some reason today I collapse up on stage, you know I'm having a bad reaction to the vaccine. So far, so good. I've been self-medicating with water and Tylenol, so I'm confident that I can make it through the rest of the day. Feel free to come up to me at any time today if you have any questions about woodworks or mass timber. I've provided assistance on a lot of mass timber projects, and in reality, they're really cool. I know it sounds a little contrite, I guess, but I think it's going to be really one of the options that design teams and developers are going to look at in conjunction with steel and concrete as we move down the road. This is not some flash in the pan thing. This is a material that obviously has great sustainability aspects to it. Hopefully Aaron is going to talk about that a little bit later when he talks about Texas forestry. We have a material that is pulling carbon out of our environment, storing it within the structural material of a building, and then obviously creating very attractive and gorgeous buildings. Moving forward, I think we're just going to see more and more of mass timber. I will be addressing the mass timber manufacturing in my presentation, and we're going to see more manufacturing coming online over the course of the years as the popularity of the material picks up. So we're really looking forward to the bright future that mass timber has. Is that 4 minutes? Did I get 4 minutes? 2 minutes of shadow puppets. All right, I didn't know I was going to have to vamp this much up here. So I know Tour A is already left, but if you're in one of the later tours, I've already had the opportunity to tour through this building here on campus, and there's some really interesting features of the project. A lot of A lot of the spaces are going to be exposed, or we're going to see this mass timber utilized as the finished material within the space. The lobby area and the stair. Has the stair been done? Last time I was here, the stair wasn't quite done. The stair's done. All right, that's going to be really cool. You're going to see a mass timber stair. I think ultimately the lobby space is going to be really the most attractive feature of it. But there's a lot of spaces, lab space and auditorium space, where we're going to be looking at a lot of exposed mass timber. And I think it's going to be a really benefit for the students as well as the staff that are working within that space. There's been a lot of studies done on the human experience with mass timber, the biophilic response to natural materials. And we find a lot of stress reductions in people that work within these spaces with natural materials. And what we're starting to see is that large corporations are sort of embracing this for their own employee experience. Probably the closest and biggest one to here is the Walmart headquarters in Arkansas, where Walmart is investing lots of money into a brand new campus with a lot of natural materials and mass timber involved with it. We see Microsoft, we see Google, we see Amazon, we see Apple, all these major tech companies that are investing in mass timber buildings because they know the experience that their staff has is a pleasurable one working in it. So employee retention is another thing. So with that, I'd like to welcome our next set of speakers to the stage so they can talk about mass timber 1 year later.
So good morning. My name is Chuck Smith. I'm the Associate Vice Chancellor for Construction here at the college. As you can tell, there's a little bit of artificiality because we are live streaming the conference. And so we want to stick to our calendar. So that's why we were trying to fill in that dead airspace. So welcome to the second and probably final Gulf Coast Mass Timber Conference. Our presentations this year are a little bit less polished than they were last year, due in no small part to having lived a year with COVID and having survived a highly impactful winter storm during the prime preparation period for this event. But at the same time, the information that we have for you, I think, is perhaps a little more real and maybe more useful to active practitioners. Perhaps the biggest lesson learned from this period of history is that you can't predict the future. At the last Gulf Coast Mass Timber Conference, we were just a few weeks away from our world changing due to COVID, but it was not even on our radar. While we were sharing photos like this one with our board, the challenge that I was most concerned about was not environmental sustainability or global pandemics, but construction cost escalation. Our 2015 capital improvement program was planned in 2014 with an 18% cost escalation provision, which took care of us into 2018, but it was already 2019. We had already realized a 22% cost escalation, perhaps more if you considered the double whammy of Hurricane Harvey and the state's early adoption of the IECC 2015. Because of phasing concerns, it looked like the best we were going to be able to do was to complete our proposed classroom building in 2021, by which time the forecast was that we should expect a total of 32% cost escalation off our original bond. And that, of course, meant either that we might go drastically over budget, which is not an option, or that the signature general education building in our portfolio would need to be scaled back to the point where it's a disappointment to some of our stakeholders. We resolved nearly half of the program's escalation gap by accelerating the construction program-wide at the cost of severely stressing our construction function. As you can see here, in 2019, we doubled the amount of construction that we put up from 2018. It was a challenge. So the AECOM construction management team and the director of construction, Mike Harris, have my undying gratitude for their efforts during that particular year, as they do for their continuing efforts right now. But 2019 was our high water mark. As near as I can figure, our collective acceleration efforts saved the program about $35 million in spending power, without which our final projects would be very different. Unfortunately, we were unable to accelerate the classroom building by more than a year because of all the interconnections imposed by its master plan site. The new building could not be built until the predecessor buildings were raised, but that could not happen until all the programs that they housed had new homes. Renovation of the adjacent Davison building couldn't begin until the process technology programs moved into the new Lyondell Basel Center in the summer of 2019. Relocation of the drafting program had to wait on completion of the South Campus Engineering and Technology Building in the fall of 2019. Culinary and cosmetology programs had to wait on completion of the North Campus Culinary and Cosmetology Building in the spring of 2020. A home had to be found for our fire protection program, which ultimately happened in the summer of 2020. And finally, the campus IT function, along with the criminal justice and audio engineering programs, couldn't be moved until the Davison building completion, which was anticipated in the summer of 2020. Only at that time could demolition of the predecessor buildings begin, which meant that our best case for construction is the window that we actually hit. Adding to those anxieties, the construction press at the end of 2018 had nothing but bad news for the future. So as you can see here, that's all the headlines were in 2018, 2019 is cost escalation is unrelenting, anticipate prices going up this year by another 5 to 7%. There were tariffs in the news, lots of things going on. So for that reason, we began to look at some alternate construction methods, such as this composite concrete and timber project at the University of Arkansas as a possibility for delivering the central campus classroom building. In addition, we mined all of the capital improvement program projects that had obtained cost certainty for savings so that we could bring forward recommendations to our board. As we went through 2019, it seemed clear that steel prices were likely to continue trending up, although with significant volatility due to tariffs, but that the cost of lumber was likely to remain stable, if not trend downward. These curves are not relative to each other, but relative to their own market pricing as a percentage of their historical commodity price. And neither one of them anticipated the impact of COVID. So most of the people in the room at this point know that commercial construction stopped, which lowered the price of steel because nobody was taking it. And everybody that got stuck at home, couldn't go into the office, started replacing fences and remodeling their houses, and the price of lumber tripled. Fortunately for our project, we ordered our timber before those impacts took place. By May of 2019, program leadership and the team at Kirksey had devoted a significant amount of effort into evaluating mass timber as a sustainable and economically conservative approach to a new classroom building. We came to the conclusion that within the size range that we were looking at, mass timber, composite steel, and cast-in-place concrete were all cost competitive. Mass timber had the advantage over composite steel in that it was likely on a declining price curve without tariff volatilities. In terms of sustainability, mass timber outperforms concrete or steel by several orders of magnitude in carbon sequestration. With great trepidation, I therefore asked the chancellor and the board if they would be willing for the college to explore the mass timber option with our authority having jurisdiction, which was the city of Pasadena. Because we had done our homework, we were able to answer the two obvious questions: how would it fare in a flood, and how would it fare in a fire? With surprisingly well, and better than you might expect, or better than we have now. As a result, our board approved us moving forward with mass timber. Shortly thereafter, the city of Pasadena's building official and the fire marshal indicated their support, and we began gaining momentum. So, looking back on our progress to date, what are the lessons learned from the owner's perspective? First, we committed to mass timber with both feet and wholeheartedly. Everything I had learned about the economies of mass timber made clear that many of the potential economic benefits were lost because designers kept leaving their options open, and thus were unable to capture the benefits of timber because they were simultaneously designing for timber or steel or concrete, and costs quickly got out of control. We streamlined that process up front. Second, we put adequate funds in place. Once we understood the magnitude of the potential cost escalation we were trying to overcome, we sought permission to realign all of our uncommitted and salvage budget from completed projects to ensure that this project could be delivered in a first-class manner. There is no doubt that we could have built a different structure for less money. However, that more economical structure would not have been worthy of being the new instructional hub of our original campus. The board's foresight in allowing us to update our budgets to account for our previous successes and to protect against cost escalation, combined with the elimination of volatility, allowed the team to keep pressing forward every time we hit a design gate and we're still within our approved budget. Third, we assembled the right team for our project. We looked at many potential partners, but we selected the ones that we believed were going to make this project work at this time in this place. We selected Kirksey as our architect because we knew they were internally up to speed on what was required due to their prior efforts to bring mass timber projects to fruition with 2 other institutional clients. We knew they were eager to do a project like this, and we knew we would get our money's worth out of them. Together, Kirksey and the college selected Tellefson as the construction manager. There were other firms who could claim that their firm had built a mass timber project in some other place with some other group of employees, but Tellefson had internalized our admonition during solicitation to identify where their weaknesses were and to provide a roadmap for correcting them before we got to erection. Finally, we literally spoke to every mass timber manufacturer in the world. With Tellefson's help, the team narrowed those down to 4, then to 2, then to 1. We might have saved a few dollars with a different choice, but we ended up with Nordique, who seemed to understand our needs and were willing to invest an enormous amount of time in helping us mature as a mass timber project staff in order to ensure technical success. Next, we forced the design to be upfront. Everything you read about mass timber says that success begins with a good model. There were several times along the way where various partners began to question the value of that effort because it flew in the face of how they normally do business these days or required a time commitment that they did not see as necessary at a particular point in time. At those times, the team had the courage to remain committed to the path we were embarked on. The payoff is in a comparatively trouble-free erection with minimal requests for information and owner-architect contractor meetings that average roughly 20 minutes in length. Over some argument, I forced the reuse of foundations, which is a common practice in Europe. The simple reality is that 3 stories of mass timber weigh less than 2 stories of cast-in-place concrete. Had this gone the way I had hoped, salvaging foundations would have saved nearly $1 million and 2 or 3 months of construction time. This should be kept in mind on any mass timber project that involves the reconstruction of buildings that have exceeded their useful life, but still have solid underpinnings. Finally, all of the above decisions allowed us to take advantage of other opportunities as they came along that we might not have had the time or ability to deal with on a conventionally executed project. The adequacy of the revised budget for this project, the excitement about making it the best project it could be, and the time the team had once the basic structure had been designed, allowed a number of beneficial upgrades to be captured as we went along. These included salvaging this bas relief, I've been corrupted by the project team. This bas-relief sculpture from the facade of the old Anderson building to become a focal point of the new lobby. Salvaging early all of the marble cladding that was used on the exterior of the predecessor buildings to be reused at key places inside the new structure. Incorporating significant graphics into the building to both link the new building to the history of the college and campus space and to educate users about the sustainability features of the building, including not only mass timber, but also the same long-wearing terrazzo floors as the college employed in its original buildings, the addition of a 391 kilowatt solar photovoltaic generation system on the building's roof, which will generate more electricity than the building uses directly, or about 40% of the building's energy needs. The reason for the disconnect there is we're also served by a campus energy plant that we get our chilled water and hot water from. Depending on your assumption set, there was an argument to be made that those solar panels nearly save enough to allow the building to operate at net zero energy cost, which is why this graph was prepared. But we decided to let history validate that possibility rather than claim it up front. We also incorporated smart sensor technology into the building, which will not only control lighting systems, but will learn how people use the building, tell us where people go each day so that we can more smartly deploy custodial resources, and may allow individual occupants to have any space they are working in customize itself to their comfort settings. And then there's the incorporation of a gray water and condensate recovery system that will reduce the amount of cooling tower makeup water that the college needs to purchase from the city of Pasadena. As far as what we did wrong or might have done better, these are my thoughts. Because we knew that the technology of mass timber was sound, our major avenue for potential failure was going to be in execution. We therefore proceeded exactly as our supplier advised us with regard to erection. As you will hear, erection was pretty slick, but we could have doubled or tripled the rate of the plan that we actually committed to. Everything that we were told about floors related to the acoustic challenges inherent in mass timber. So we included 2 inches of rubber between our concrete slab and our mass timber deck. And we were coordinating so many details the first time around that we didn't do a high-level review until too late in the process. So we were working on details and we finally got back to thinking about, do we have to do all this? And we're still trying to figure out what that actual answer is. But it's not too early for us to say that with a few minor changes in the assumption set, there was a potential for significant savings. Finally, while I'm still a believer in the reuse of foundations, it did not become apparent to me until too late in the process that we should have forced the footprint of the new structure to largely follow that of the older structures if we really wanted to benefit the most from reusing a foundation. And Justin Smith with Walter B. Murrow will talk about that in a few minutes. In the end, all of these issues are related to poor or imperfect communication, which it was my responsibility to ensure. But what I do know is this project is delivering a university quality building for our future students and faculty, one which definitely looks to the future, but which is also rooted in the history of San Jacinto and the Central Campus. And if any of the partners on this project were to build another mass timber project, we could build a comparable structure in less time and for less expense. And with that, I'm going to yield the stage to Steve Durham with Kirksey Architects.
Great. Thanks, Chuck. That was good. That's a lot of good information. If you're hearing about mass timber for the first time, you'll absorb this stuff, and it really is not going to make a lot of sense until you get into a mass timber project. So all the things that Chuck mentioned were dead square to what we have been finding out, particularly over the past year. And over the past 3 years that Kirksey's been sort of going down the road of educating ourselves. I'll just tell you, 3 years ago, Daryl and I, who worked on all the mass timber stuff in the office that we're doing right now, didn't really know that much. I mean, if you're in that boat here today, you're at a good starting place. The first thing we ended up doing together was going to the Mass Timber Conference in Portland. Next year, when it hopefully becomes another live version, you should go see that if you're still interested. We learned a lot. And mostly what we took away is that this is real. This is not just pretty wood things that we see in building that look expensive, but we saw fasteners, we saw screws that were 15 inches long, we saw brackets, we saw the adhesives that they glue all this together. We talked to manufacturers, they had samples. It all of a sudden at that conference became real. And I think that's what was most important, because then we could come back to the office and talk to designers and other team leaders in our office about mass timber. And I can tell you, when we got back and talked to the rest of our team and designers, we were so excited, and they looked at us like we were Martians. Like, that's great, that's neat. They were on to the next thing. And it dawned on us that we really, if we're going to see this through and push it through and be serious about leading our firm in this regional area about mass timber, then we need to stick with the game plan, which is educating people. So we embarked on a road. Chuck mentioned University of Arkansas. My son happens to go there right now. And so they have the largest mass timber structure that's built right now. When I was making my trips there to see my son, it was under construction, so it was fascinating. But Nabholz is the builder. They had never built one before. So I talked to them multiple times. In fact, they were here at last year's conference, if you remember, talking just about the lessons learned from that. So, you know, the key was for us to get out and go see projects and talk to people. And that's what we did. Nabholz and all those guys became a resource. And I hope after the end today, after you see everything, if you need to call us to ask questions, feel free to do that. I'm certainly be happy to answer any of your questions about projects. So we, when you walk away from here, hopefully you can be the ones that'll be the cheerleader in your office, because if you just go back and talk about it today and walk away, it'll just be another one of those trendy things that fall on the wayside. So it does take some effort, but it is exciting. Big one, thanks. Big one that says push here. So what is mass timber? There's going to be 100 definitions of what is mass timber when you start to get into your research about this. I've read through a lot of those. They basically all kind of say the same, but I did come across a good article, I thought, by David Roberts in Vox.com that sort of put it this way, which is it's a material that can substantially reduce greenhouse gas emissions. It can slash the waste, pollution, and costs associated with construction. And as designers, create more physically, psychologically, and aesthetically healthy built environments. And if you know Kirksey, anything about Kirksey, we're a sustainably focused design firm, so that was important to us. But why use it? Again, you will find lots of different things out there that say, why use mass timber? Well, it does perform well in a fire, and tests prove that. It reduces carbon emissions for sure. Buildings can be constructed faster, depending on the route that you go. And it can help pay for good forest management through the use of FSC certified wood. It can create jobs in struggling areas, which I think we're just now seeing across the southeastern United States, with manufacturing facilities popping up that are addressing the needs of private timber landowners. And there's really no other good choice. If you have a certain number of these sustainable things you want to look at and check them off your list on your project, there really is no other better choice. In fact, I mentioned FSC wood. Sustainably harvested wood sequesters a third more carbon than unsustainably harvested wood. And mainly that is because there's some oversight. There's the sustainable forest includes programs involving soil management and optimizing growth cycles, among other things. But it is essential to get that benefit with the carbon reduction by using the products that have FSC label. There are others. There's a couple others. We're seeing more Sustainable Forest Initiative, SPI, SFI certified wood. That's becoming, I guess, we're seeing that more as we get into research. I know primarily here in my career and on the Gulf Coast, FSC wood has been the thing that comes to mind. But as you know, your clients, our clients, sometimes they just require steel. They might require concrete. We can have that conversation, but you know, we have to deal with these other materials too. The largest manufacturer of steel products in the world, our seller, Mitel, is certainly trying to make efforts into creating or reducing carbon, creating carbon neutral steel. I think personally, the concrete industry and the cement industry have a long way to go. In fact, the little text at the bottom of that cement plant there says global cement production is responsible for about 8% of the world's carbon emissions. So I do think they have a long way to go, but I think essentially we're starting to find players in the market that are addressing the need to have a response to carbon neutral and climate change in the economy. Mass timber products, there's a lot. So we know it's glulam and CLT, cross-laminated timber, but there are other things to be out there and to note that it's not just one or two things. There's parallel strand lumber, which a lot of us might be familiar with in terms of beams. There's mass plywood panels. There's nail laminated timber, dowel laminated timber. Those are two options that don't involve adhesives, and that is important. Of course, I think most of what you'll find, most of what we're seeing, most of what we're talking about in our conversations are glue lam, columns, beams, and cross-laminated timber or CLT. So why mass timber at San Jac? Chuck laid out a lot of why from their viewpoint. I think, again, my presentation is really about from the designer's viewpoint, from the architect's viewpoint. Clearly, the required construction, which does not become apparent until you go to a job site that has a mass timber project under construction. It's eerily quiet because there's 6 guys on site. One's in the crane lifting. Another one's tying up the connections to hoist it. And there's a couple on the building over there. It's just kind of weird. That only happens, of course, during the erection process for the most part. Reduce construction time. That's important. There are ways to really address construction time issues. And that's what we're talking to our clients about. Reduce foundations. Justin will talk more about that, but it is pretty interesting. And aesthetics, as designers, this is important to us. So we see a lot of that. And fortunately, we had a client who was focused on, aesthetics are great, but the dollar is important. The budget is important here. And that was a good balance, I think, in having that with our project. So just some things I want to mention that sort of we've put together over the past year of watching this structure go up. In the early part design phase, Chuck mentioned this as well. So important to talk to all the folks that are going to be have a position in your project. So that's for general contractors. We had a conference here on campus and invited a bunch of general contractors to come and said, Daryl and I presented and talked about the building and floor plans and all this neat stuff. So they got to see it and ask questions about it. So there was sort of an education that happened even before selection process. Interview mass timber suppliers, very important. We had a number that we reached out to. We had large team meetings where we went over a lot of material. The mass timber design assist, once you have the mass timber folks lined up, was so important. And this image, I think, is the subtlety of it. I want to point out that while you had this VP in the room and that VP in the room and this vice chancellor and that VP of construction, all these VP people in the room talking about it, you have to have the folks that are drawing and modeling and creating the thing in 3D. They need to be there in all the meetings at the front because they have to know what they're getting into. And there'll be a lot of reasons and a lot of questions that guys like us can't talk about in terms of BIM 360 modeling and all that. You have to have the folks in the room that are going to be putting this down on paper, so to speak. Holistic pricing is important. Early on, without a contractor on hand, we did our own very unscientific pricing. We put some sketches together, sent them out to a couple contractors, more than a couple. Two responded, 2 said, this is crazy, we're not doing that. So they didn't. But the importance of understanding, you can't get pricing. You can't ask your contractor to price a wood structure and a steel structure and then compare it. It's just not going to be fair to the project. Part of your cost savings is going to be in schedule. Okay. So I circle structural frame there to point this out because ultimately what happens is you will come across a contractor or whoever's doing the pricing. There are lots of other companies that help do pricing that have such a disparity in their number. You just start to wonder, maybe they weren't all that excited about it. Maybe they decided not to do the research that led to this great number. So if your client is going, wow, one is 9 million, one is 3 million, well, heck, we're going to do that one. Dead project right there. You haven't even got past the end of design and the project is dead if you want to do mass timber. You have to look at the whole number at the bottom line. Grid layout is so important. Justin could speak to that, but without understanding the importance of grid, the depth of the beams, the mass timber manufacturers talk about the volume of fiber. So that has nothing to do with how big a glue lam beam is or how thick that is. They're talking about the overall volume of fiber. So we analyze that The classroom building like ours goes great because it does have a module. We're doing a housing building at Rice. As you can imagine, a dorm room, very modular. It's working out great for that. It's so important. We ended up going with option one here for our, because it was less volume of wood for the structure. Utility routes need to be planned. I see Heather out there. Understanding that and modeling every little thing, you have to understand where those pipes are going and what beams are penetrating. Code issues about you can't, this is a type 3B project. You can't have your wood structure in the exterior wall. We had a little overhang on our CLT decks that went over the, that got into the wall. So we had to do special fire treating just on the part that overhung. So you'll see the red type of wood, that's fire retardant treated plywood covering up that section. Very important. We talked with the city of Pasadena about this. Great. We submitted it for Rice, talking to the city of Houston. No, not going to allow it. What's your next option? So it's just, it's not the same. You have to get the city officials involved. You have to work with them, work with the fire marshal to find out what they'll accept. We did find a solution. So this is a series of images. So when Daryl and I went to the conference, we didn't see these images. Nobody said, hey, the wood splits. Hey, there's adhesive leaking out. There's, you know, it gets messed up at the jobs. No, we saw a bunch of pretty pictures. We didn't see these pictures. So immediately, Melika, our PA, goes out to the site and sees all this. And, you know, it is a mild panic. You're like, what? Oh my gosh, what do we do? So there is a solution for all this. What we did is the wood sections got installed. We went out, documented, made notes. Essentially, we did a punch list, provided to the contractor. I think everybody appreciated just having this. So all these things can be addressed, and they can literally replace pieces of wood if need to in sections that are damaged too much. So it's not too much to get stressed out about. It rains, so have a plan. What we heard most from the University of Arkansas project with Nabholz construction, just have a plan, have folks, have a guy dedicated to squeegeeing off the water every time they come to the job site. If it's sitting on the wood deck, just squeegee it off, you'll be okay. We learned a little bit more about what happens when you got the acoustic material down and you have a pour edge around the perimeter of the building and you're ready to pour tomorrow morning, and that night comes a downpour and water has nowhere to go and it sits up there all night long, and you come to the job site and there's 1/2 inch water everywhere. What do you do? So there was a plan. Eventually, they came to the quick conclusion that they needed to cover up the building, which you see the plastic on the building. I don't know if that's the best response. It was what we did there and it worked, and they got on down the road. So I think we would have probably a different response next time. Pouring on the deck, it's just, you know, it's a busy time. They're all crammed in. They're doing a bunch of work. You got to protect the wood as best you can. That's important. And I'm sure they had discussions with their installers about doing that. Show the block out there at the bottom of the column. Great idea. Tellefson had to do that to make sure that we're isolating any potential for building movement and cracking. So it just solves that. It keeps it very local right there to the column. And they moved on. There are hybrid systems. Chuck mentioned that a little bit. You can utilize steel structure and a wood deck with CLT. You can do a mass timber structure on a podium, concrete podium. That's all a possibility too. There's examples of that around the country. So there are different ways. Our project, which we wanted to stick to, was as much as possible fully wood constructed frame. We did end up going with some steel lateral bracing, steel lateral bracing, just for a number of reasons. It was the right choice. So you'll see some steel X frames out there for lateral bracing. Terminology is important. There's a whole new list of words you need to learn. There are two CLT products in this image. One, some of you are very familiar with. A lot of construction jobs will have CLT drive mats there. There's a big firm and company in Lufkin that produces this. It produces a lot of it. That is CLT essentially. That's a 3-ply CLT drive mat. Our CLT is a 5-ply. in the building. It's from a certified manufacturer, and that's the difference, a certified product and a not certified. Workflow, I'm sure Pat's, what Telbson's going to talk maybe a little bit more about this, but it's true. Once the structure kind of gets up, there's not a sea of supports holding up your concrete floor that was poured 3 days ago, and nobody can get in there and work. Essentially, the ground floor, once the deck is on and they've moved up, you can get your subcontracting crews in there to start working and hanging stuff. CLT walls. This is of interest. The project, University of Arkansas, it had concrete shaft walls, elevators, stairs. I remember talking to them about it. They could have had a solution with wood. The fire marshal at the time was very uncertain about wood and shafts, and they decided, let's not argue about this. We're just going to do concrete CMU block. That's what they did at Arkansas. So we had that knowledge, and we came back to our code officials in Pasadena, who were very willing to work with us. And I remember that meeting. We all sat around the table. We showed them this, and we thought they were going to be, wow, this is great and all that. And they're like, well, that's nice. Are you going to design and build it to code? And of course, the answer is, yeah, we're going to design it and build it to code. They said, great. What else do we need to talk about? And we came prepared with graphs and charts and all this stuff. And so they sort of started to get up, and we said, that's great. And by the way, the elevator shaft and the exit stairs are going to be made out of wood paneling too. And that caught their attention. They turned around and gave us a funny look and said, that is something we are definitely going to have to talk about. And so we did. We talked about having big, giant, standing the CLT panels on end to go up 3 stories, one big panel. That took some discussion, and ultimately we got to a point where we were able to use that, and it's installed up there and you can see it. But the point is, whether you can or can't, it's just you have to have a discussion about all these components to get the authorities sort of up to speed, because some are not familiar with it. Coring through wood, you don't want to get to your job and make a habit of having to core through wood. You can, it's wood, right? That's what we kept hearing at conferences and things like that. But go home and physically go get the biggest drill bit you have and start trying to go through about 7 inches of wood. I mean, it's not easy. It takes some labor, but Telbson had guys out there that were prepared. They have, in this case, I think that's coring drill that allows them to go through. So it is important to understand there's a finished side to the CLT panel and a not finished side. What's going to be seen, what's not going to be seen, because wood, drill bits, they can splinter on the other side, and it's just something to deal with. In our case, we came up with a solution that I thought again, we never heard about this at a conference, but this makes complete sense. In the hallways, we didn't want, if we had pre-cored holes in the CLT panel at the factory, we didn't want somehow to be 1/2 inch or 1 inch up, close, but not quite, because you're getting that straight view down the hallway. We wanted it to be perfect. So we didn't have it done with the CNC machine at the factory. We came back, once everything was in place, chalked a line, got the drill holes right down the middle, but we had planned for it. So it's a great solution. And there are a lot of little things like that in the course of a project that I think is important to understand. Also, we wanted to see the wood in the hallways, right? We know you look up, you see wood. It can't be 100% wood everywhere. There's got to be infrastructure, got to be ducts and piping and all that stuff. You have to plan the areas that you want to see the natural wood. Lobbies are great, obviously, but what about the rest of the building? So our strategy was, if you can see, looking down the hallway, on the left-hand side, you see all the infrastructure going. That's going to be in classrooms. It's going to be covered up. It's going to be in ceilings. It's going to have access and all that stuff. But the hallways are going to be nice and clean and crisp. So I think that was a design feature we wanted to focus on. So working with mass timber definitely requires pre-planning to understand manufacturing differences. It's easy to understand in terms of how this goes together, right? It is like a tinker toy type thing, But you have to get it right in the model. The BIM model is so important, and you have to educate your team why you're doing this, because they don't know. They don't have all the background. You didn't take whole teams to the conference and get all excited about it. They don't know. So you have to educate them, and eventually everybody can get on the same page. But what we found out is there's 100 different reasons why you can say, you know, let's not do this out of wood. Let's just go back to what is comfortable to us. You have to stay focused on the end goal. And fortunately, we had a client who was, and he mentioned it, they were all in for good or bad, they were all in on the wood. So that made a big difference. A little bit about the project. We're replacing 2 existing buildings. We're tying on to an existing building, Davison. And Chuck used, of course, the mass timber as a way to protect against price fluctuation. That was an important part for him. The part T of the project here, the volumes of spaces that we needed. You can see the designers, how they shifted, tried to give it some interest. We really tried to keep the design simple. And I think that was important. With our first mass timber project, we really didn't want to try to do some weird things that it's not set up to do. And I think the more we understand it, the more we can venture into that design part of it. But I think we wanted to keep a pretty simple building. Quieter on site, all the solar panels, which were an alternate for a length of time. And then eventually it was decided, let's do this. So they're doing it. The gray water system is interesting. The sage glass, the electrochromatic glass, if you will, on the curtain wall sides there. And of course, the educational branding throughout. Our team at Kirksey is going to help create some educational branding boards that'll be throughout the project. So just the general layout, there's a 3-story structure. And then the 2-story structure facing the parking lot connected by a 2-story volume lobby, what you're going to see out there. It's, again, pretty simple. These are simple volumes. There's brick, there's curtain wall, and hopefully at the right time of the day, you'll be able to see the wood expressed on the inside. We did decide to make the lateral bracing there on the end, express that in wood, which is an option. It would have been an option for every lateral brace in the building, I think. But again, some of that is steel, but we wanted to express it here sort of at this main entry point. The lobby was the one place that we decided we could sort of create some interest with design features and things like that. So we did, Michelle Old, our designer, and Melika and the rest of the design team really did a lot of studies about looking at the lobby. What can we do? What can't we do? We talked about bending the wood and what's the radius you can bend glue lambs and all that stuff. We eventually landed on this double beam, double column system, which provided some interest. Again, it's pretty simple, but by having the double beam, double column, we are able to in fact hide some of the infrastructure in between those in the dark shadows. So we are utilizing places that we can for sprinkler pipe or lighting, conduit, electrical conduit and such. And then the goal was to try and keep it as clean as we could. So we saw a lot of examples of mass timber buildings that just had a lot of, lack of a better technical term, a lot of goop up in the ceiling that just was kind of running everywhere. And we wanted to be prepared for that in our design, to try and not have that clutter up the ceiling. I show this is a big room, presentation room, but we have some acoustic attenuation in there, suspended. And Daryl's going to talk about acoustic issues in a building briefly in a later presentation. But acoustics are important. We didn't have an acoustic consultant on this job. We did a lot of the research ourselves to try and find out what we need to do. We did that, but it is an important feature. So you would think about that if you're able to work on one. And this is I'm going to have him cue up this video in a moment. We did a lot of drone footage. We've for this project, we've hired a fellow to come out and do a drone run every now and then, a professional photographer to document the building going together. So we're going to create a lot of material that we want to share and create some educational access for others to see that. But if you could start the video now, it's just a quick video showing the part of the installation. So just in closing, you know, it's not just a sort of side thing. I mean, mass timber is happening, and it's all in part of the larger conversation about climate change and carbon neutral and all that. And just in the paper this week, there's articles every day, it seems like, talking about things that address all of this as a whole. In fact, I know Gensler's, released a statement. A lot of firm have, but they in the article specifically, for the first time that I can tell, in as long as I've been sort of tracking this in the Houston Chronicle, at least, it actually mentions mass timber as an option, as something that absorbs carbon as they grow. Engineered wood has a potential to be a green building material. And I would say, I think the potential is sort of gone. It is an option. It's not potential. It's there. It's here. It's exciting. We are, embracing it as much as we can. And I would tell you to do the same thing. We got in the car. We made appointments with folks. We said, we want to come see your building. We went up to Denver. We've been to San Antonio. Of course, we've been to Portland and Seattle. Been to Arkansas. We wanted to see other projects for our education, so that when we take this to a client, we know what the heck we're talking about. And so I would advise you guys do the same thing. It's starting here today by seeing this one. This is a good one, but there are others. Also, do your research. There are thousands of places you can go find this information. Woodworks has been great. We've relied on them a lot. There are some universities that have their own institutes that are following this. Chuck mentioned the vibration study. University of Arkansas is doing a moisture study, ongoing moisture study. So it is happening. And of course, we want to know what's relevant for the Gulf Coast. That's what's important to us. And I think that's now with the information that's being generated, what we're getting. So I'd be happy to answer questions at the end. I know, Justin, you might want to make your way up. But I'll say this is real, and it is happening. And I can tell you in the last 2 weeks, I believe we picked up 3 mass timber projects. So clients are getting wind of it. It is happening. And you don't want to be wondering if you should have got into this, a year ago when everybody else is sort of getting the jump start on you. So in this part of the world, I would advise you to take an interest and get excited about it.
Steve and Chuck. My name is Justin Smith, and I'm with Walter P. Moore. We're the structural engineer of record on the project. Go back one. Thank you very much. Actually, Steve and Chuck teed up the presentation here perfectly. I start off talking about the existing foundations, and these are the 2 buildings that were on site prior to the construction of our building. And Chuck really pushed us in the beginning to explore the reuse of the foundations from these 2 buildings. They're 2 two-story concrete structures, concrete second floor and concrete roof. This is the plan of the existing foundations overlaid with the existing buildings in red outline and the new building in green. And I don't really want to get into a debate of architecture and the difference between contemporary architecture and program space and what the footprint of a building looks like today as it did opposed to what it looked like 50 years ago. But that's really the deciding factor in why we didn't reuse a lot of the foundations. Although our foundation system on this building is a scheme, it's like a hybrid between new and old. And this is the field of existing foundations. So the existing buildings are concrete buildings. They're concrete moment frame buildings. From a structural standpoint, the existing buildings are twice as heavy as the new mass timber building. So we're doing 3 floors of mass timber for less weight than the original 2-story concrete buildings. And that's what really got Chuck excited about reusing the foundations. It's also tempting to look at these foundations just in the layout and the use of space, and that the module of the existing buildings is about 16 feet base spacing in one direction and 40 feet in the other direction. And when we started this project, we were looking at a base spacing of 16 feet by about 32 feet, and we wound up at 15.5 by 28.5. So that's what worked with the classroom module. But you can see we're very close actually to the concrete skeleton layout of the original buildings. The issue arises with the lateral system, and I'll talk about that a little bit later on in the presentation, but these concrete moment frame buildings distribute the wind force to each and every pier pretty much evenly. And in the mass timber building, that's not possible. So we need to have concentrated wind forces at some location in the building. And even if we had built like for like buildings, mass timber on the exact floor plan of the existing buildings, we still would have had to have done quite a bit of foundation work for the brace frames. And I'll show that later on in the presentation. So this is the new foundation that we put in, overlaid with the existing foundation. And like I said, it's a hybrid system. What you see in red are foundations that we had to pull out. And the alternative, really the only alternative to what we did on this site, was to go in and pull out all of the existing foundations. And structurally, that's of concern because we don't want to disturb the natural soils on the site and cause ourselves any future potential risk of building movement. So we wanted to leave that foundation system in place. And if we're going to leave it in place as densely packed as it is on the site, then we want to reuse as much as possible. So this again is the final overlay of the two systems. The black piers are existing, and you can see they're really densely packed on the site. They just don't align with the columns that we needed for our new buildings. So we have quite an intense system of transfer beams that transfer the loads from our new columns to our existing piers. And all of the piers in blue are new that were drilled in the field of the existing piers. And I can tell you that we had in the 3-story volume alone, 110 columns and 82 new piers. So we did save the delta just in a flat out number of piers per column by using the existing system. And on top of that, the new piers that we did put were always smaller than they would have been if we had raised all of the piers on the site and started over clean. So there was some material savings in this process. I'll just say that it's really analysis intensive. And I'm sure Tellefson would agree that it's quite labor intensive in the field too. A lot of unforeseen conditions, as you can imagine, when you get into this. So this is the structure overlaid with the foundation, and it starts to look really like a normal building. Here you can see I've highlighted in red the steel on the project. So I wouldn't call this really a hybrid building, but it does have a fair amount of steel. The steel is used at external egress stairs you'll see on the tour, and we did that for durability reasons. We wanted to have galvanized steel in the exterior conditions for structure. And then we also have a steel lateral system in this building. And that was a big early decision. We looked at CLT shear walls, and CLT shear walls in the beginning made a lot of sense for us. We definitely explored that with quite a bit of enthusiasm. It didn't price out. One of the major drawbacks to the CLT shear walls for us was the allowance for MEP passage. So we get a much bigger brace frame with the steel. The bay is twice as wide as you can see here, but we still have a lot of opportunity to run mechanical and electrical through the space. Our original layout of CLT walls looked like this. So it's an awful lot of walls. And this is really the shortness of the wall causes the hold down force on the end to be quite high. And that's why we need so many walls. And then that's the reason why it didn't really price out as competitive with the steel cross braces. It's in hindsight, there was a lot of discussion about the aesthetics of the hold down of the CLT wall. I think we'll get more and more comfortable with these hold downs as time goes by. I mean, real honestly, it's not any more intrusive than the steel, what we're used to on the brace frame. I mean, it looks quite different, but it looks just as easy to conceal. So what you see on the right is concealable, just as what you see on the left. And the picture on the left is from Colorado, and that's not as high a wind force region as we're dealing with here. So that's something also to consider. I mean, Gulf Coast Mass Timber Conference on the Gulf Coast, we have really high wind forces, and it's something that definitely affects the design of our building. This is a really something that I'm happy to have been able to compare. Believe it or not, this is a steel building that the exact same team did, Kirksey and Walter P. Moore and Tellefson, about 5 years ago. And it's almost the exact same building footprint, about 300 feet by 100 feet. And the 3-story volume, the 3-story mass of our new building is approximately the same. The floor plate in the steel building is 26,000 square foot per floor. And in ours, it's 33. So there's a little bit of difference there. What I found in comparing these two buildings is that the structural weight is just about the same when you look at beams and girders and columns. The mass timber building has 110 columns shown here, and the steel building has 35 columns. But the mass timber building is a little bit bigger square footage. So if you scale that down, it's about 86 columns in the mass timber building per 35 columns in the steel building. So you get a lot more columns in the mass timber building. You don't get a lot more weight. The foundations, actually the foundation system on the steel building is quite a bit heavier than the foundation system on the mass timber building. So we still save money in the foundation, despite the fact that we had to build a lot of transfer girders to reuse existing. Our structural weight in terms of the skeleton is very comparable, and the big delta shows up in the floor plate. So our steel building had a 4.5-on-2 composite deck, and that was 72 PSF, and our mass timber building is 52 PSF. So that's a huge savings when it comes to foundation. As an aside, there were questions during the design. Well, why is it that does this help our overturning moment at the brace bays? And what's the impact of having a mass timber building at the brace bays? And it's not so much that the building is considerably lighter, and so we lose some assistance with the weight of the building for overturning moment, but also the tributary area to those brace frames is quite small. I mean, because the bay size, the bay module in the steel building here is 30 by 40. And like I said, we were going 15.5 by 28.5. So that tributary area to the brace bay is small. And not only is the building lighter, but the area is smaller. So you get a lot less resistance against overturning at your brace frames. And that's going to cause those foundations to be bigger. I get this question like every week on a building, and it was such a relief to see this photo. I think maybe it's my favorite photo from the presentation. And, you know, it's right when we get into construction, the questions start rolling in of what can we drive on the elevated floors and how soon can we do it? And with the steel building that we just talked about on the previous slide, you know, you could never do this until the concrete was poured, even though it's unshored construction. So you have to bring out the concrete trade before you have an opportunity to start really working on the elevated deck. And with the mass timber building, you could do it the day of. And the guy said, hey, can we drive our lift up there? And we said, yeah, you can drive a lift up there. And you go out there, and they got 2 lifts up there. And not only that, they park them right next to each other. No issues, no deflection on this deck where these two lifts are. So I think that the superintendents out there in the field will agree that the great thing about this building from a construction standpoint is you immediately have an elevated surface that you can work on. you can really plan your construction a lot differently. In fact, I looked at the erection schedule for the steel building that we looked at on the previous slide and the erection schedule for this building, and there's really not a big difference. I think one of the caveats is that during the erection of this building, we had, a major ice storm and a lot of other difficulties on site. And the other building was built in the springtime and summer with no impediment from nature. And so this schedule got held up a little bit by forces we couldn't control. But the big difference would be we can immediately go on these floors and start doing things like internal MEP work. So all of this work was done before the concrete subcontractor showed up on site to pour the topping slabs. So this is the morning of the first topping slab pour, and you can see they've already done a ton of work on the inside of the building. So those two processes, those two periods in the construction schedule will get to overlap in these buildings in a way that they don't get to overlap in a concrete building or a steel building. So Steve showed this detail that Tellefsen proposed for the block out around the columns. And what we found during the design of this building, there are just a lot of typical details for concrete buildings, for steel buildings that don't exist for mass timber buildings like this. And so we're tasked with having to invent a lot of those details. And this came from Tellefsen. We really like it. We're doing a similar building and we're going to use this detail. Hopefully they haven't copyrighted that yet. So I get the thumbs up here that we can go ahead and use it. It worked really well for us. And I hope when you're out there today on the tour, you see that these slabs are crack free and that the control joints are placed really nicely and that the concrete work is done really well. Some steel elements that gave me some fits, but turned out to be not a big deal. And I'll just say, one of the takeaways from this project is that because it was such a new thing for most of us, there were a lot of concerns and a lot of worries about how things were going to go. And at every turn, things went a lot more simply than I think we ever could have expected. So we were concerned about how to develop the diaphragm forces, particularly the chord forces in the wood diaphragm. And we gave the loads to Nordic and they just took care of it. Oh yeah, no problem. We put steel plates here and go out in the field. It's already taken care of. We were concerned about transferring high wind forces from one building mass to another. And we did that with these steel elements here. And we designed them and detailed them and Nordic installed them, no problem. So there were a lot of things that we felt were new and inventive, and they just got done as if they were had been done a million times before. So a lot of the things that worried us, driving lifts on the slab, how the slab would perform, how details would be done in the field, actually have gone very smoothly. Mechanical penetrations, this is something that we don't do very often in steel. It's totally possible, but it just happened really seamlessly on this project. We gave the opening sizes to the fabricator and everything shows up on site and it's just right. Again, that column block out, you can see Nordic did all this work and without a whole lot of fuss, everything starts to come together really well. During our interviews of mass timber providers, one thing that struck me was the fact that Nordic provides a material that has a very small lamella. So this was one of the questions we asked the guys in the interviews is what does the material look like? And the Nordic material looks quite different from some of the other providers. And one of the things is they use a small piece of spruce glued together. So their lamellas are made of much smaller pieces than a lot of the other providers. But I go out to the side and look at the material and it looks really good. So it's just another thing that there was some questions about that turned out to not really be a big deal whatsoever. Slab edges, you can do complicated slab edges in CLT just as easy, if not easier than concrete or steel. This is a detail that we invented and I think will evolve as time goes by, and that's how to put a shelf angle on an elevated floor plate. We asked Nordic and we asked other people in the industry and nobody had a really solid detail. This is something that we do in concrete and steel every day. And this is one of the details as these buildings get taller that we'll have to come up with something that's routine, that's smooth, that's been tried. And and tested. I run the numbers on this detail many times over the course of the past year just to be sure. And this is how we're going to do it here, but it's totally invented for this project and not sure how we'll do it on the next one. It's just an example of one of the things that we hadn't seen done before that's going to have to become commonplace in the industry. Probably my second favorite photo. This conduit bend here was the topic of several design meetings, and this is really how we decided how thick to make our concrete topping in the building. It had everything to do with the conduit bends and particularly the junction boxes. So we have 2 inches of acoustic mat and 3 inches of concrete, and that 5 inches allows us to have these bends like this without any heartburn. And we get about an inch and a half of cover over the top of these, and everyone's happy. I know a lot of mass timber buildings, comparable buildings, have 2 inches of concrete topping. And I think that's probably the way to go, but 3 inches was a really smart decision on this project, and it's helped us a lot. Okay, one last thing about the lobby, and Steve talked about it and really used the exact same language that I'm inclined to use. Is we looked at a lot of precedent projects, and there seemed to be a lot of clutter in these open spaces. And Kirksey wanted the space to be quite complex, but also quite slick and free of that clutter. And so we have here many different structural elements, a CMU shear wall. We hung a portion of the walkway from the roof. Another portion of the walkway we just spanned from building to building like a bridge. Another portion of the walkway is cantilevered actually from an adjacent floor plate. So we did a little bit of everything in this lobby with the intent of not having a lot of ancillary structural elements like, too many hangers, additional steel, exposed steel, too heavy wood members, anything that could make the space heavy and look cluttered. And this is that interior space. It's starting to look really sharp. I think with the light in there, it's going to be great. We provided glulam girts, horizontal girts for the curtain wall systems. So that's what you see there, spanning from paracolumn to paracolumn. And one last shot of the interior lobby space. Only thing really cluttering up the space is the construction activities going on, and I'll let Pat Pollard tell you about that. Thank you.
Good morning. So is this hit the button? All right, so now you get to hear from the contractor. That's a pretty good talk there from Mr. Smith and our design team. It's been an exciting project. I guess a few months ago, Chuck reached out to us and said, hey, we're going to be doing another conference, and I want you to do a piece on 1 year later. We've been at this a year now. What does it mean to us? And we have no regrets. It was a little crazy when we first heard about it. It was early 2018. We had a lot of discussion coming into the office. The idea of mass timber was making its way down to our market pretty heavily. It sounded good, but we had no experience in it, so we weren't real excited about it. But we knew some of our partners like Kirksey, they were already down that road. And when Mr. Smith brought it to us, we said, man, what do we think? And we think we're up for it. We want more. It is very exciting right now in Houston. Very exciting for the college. The college has always been on the cutting edge. Those of you who work for San Jacinto, I mean, they're always out there. And mass timber, they took the lead again on it. And they're the envy of the market. And I mean that in the most positive way. Other institutions, we field those phone calls. I know Steve and his group are fielding those phone calls. The private development sector is ringing the phone off the wall. There's proven concepts in other markets such as Austin. Rents are higher. The tenants are there. They're paying. So when you have private developers now saying, how do I get into this? I get it. I may pay a little bit more premium, but my rents are going to be there and it's the right thing to do. That's exciting. And we've had no less than probably 5 developers, from residential developers to commercial developers, wanting to come out here, tour this project, they're excited about it. And Steve, hopefully a couple of those people are some of those jobs that you just saw. I mean, we're seeing a lot of opportunity there. So no regrets. We'll do it again anytime. So talked a little bit. We heard about the rumblings. For us, it was early 2018. It kind of started making its way around. I was a little bit surprised when in December of 2018, we were working with Kirksey on some other projects. We've had a long-standing relationship in Houston. And we get this email, and there it is. Your thoughts on whether this approach would make sense for a 3-story, 120,000 square foot classroom building. And it was titled mass timber. And that was the idea that it was in the email. So I quickly shift over and I go to Google and I look up mass timber, and this high rise shows up. And I was like, what? You're going to build what? What is this? So it got us excited. I reached out to Steve, and I knew they had already been engaged in this. And he said, man, this is really interesting that the college is interested in doing this. What do you think the chances are? I said, well, look, like anything else, they're going to vet it out. They're going to do the due diligence. And, if it makes sense, they're going to do it. So internally, we shared this information with our team, and we said, look, this is San Jacinto College. We know when they put their mind to something, it's going to happen. So we put together a little group internally, and it was myself, our vice president of estimating, our project management staff. We have a big group of interns that every year we've had 8 or 10 of those guys. So we put a mass study together internally, and we collected anything and everything we could about mass timber. And we started that process of education internal to Tellefson. So this is how it looks. This was the timeline. We got moving on it. The question came, and early on, 2018, does this make sense? It was January, I think, yeah, maybe less, Steve, that you guys responded back. Yes, Chuck, codes will allow it. It's something we're going to have to get with the local jurisdiction, introduce them. It's something new to the market, but absolutely, this could happen. So this due diligence process started, like everything the college does. They like to prove things out. They like to work the effort, see the result. They got there in May of 2019. Chuck Smith noted that earlier. He felt like that he had the information he needed. All the metrics were there, and it seemed like it made sense. So he took it to the board in May of 2019 and got the green light. I think it was the next day, Steve, that we got an email from Chuck saying this project is going to be real. Get ready. So that was very exciting. I think it was right around that time, shortly thereafter, the design team was brought on board, and the help was solicited to obtain some grant money that's available out. That grant was successful. And then in July 2019, we got our RFP on the street for construction manager at risk services. So not a lot of time expired there from, does this make sense, to vet it out, to get the board moving, to let's get a contractor on board. Kirksey's on board. September 2019, the Great Flood of Houston. It was one of those events. The college had their interviews all set up on that day. We had folks flying in, different partners. A requisite of the RFP process for construction manager at risk was that we have industry experts on our team. So we did. We had experts in the fabrication side of mass timber, Blue Lamb, CLT, and we had another engineer on our team with another national firm that actually one of their groups helped in the grant process. So we felt like we had a pretty good team. We were heading to our interview, and every street in Houston was flooded. So 2 out of 8 members of the Tellefson team, 2 Tellefson members actually made it to the interview, and 2 of our out-of-town guests actually made it there. And the rest of our team was stuck on the side of the road, and we conducted our interview with half the people stuck in cars and half there. Nonetheless, we pulled through. We were awarded the project in 2000 or October of 2019. And it was literally like the next day, Daryl was shooting over a Dropbox file saying, here's some drawings, get busy, let's go. I don't think we were expecting to go to work that fast, but Kirksey was just moving down the road and it was great. So that's October. The next month, we are gathering and we spent October and November talking about the need of getting the mass timber experts on board, our fabricator. And we spent that time creating lists of, Chuck noted, I think everybody in the world that would talk to us. I want to say we had 20 different material providers on that list to start with. And we did get down to, it was 5, then 4, and then ultimately 2. We got that RFP out and that process was awesome. We spent a lot of man hours sitting at Tellefson's office, making phone calls outside, individually to these people. We developed the RFQ together in collaboration, all of the knowledge we had gained, all of the knowledge Kirks and the design team had. We created this very, call it elaborate. It was a very detailed request for information because this was a learning experience. We wanted to take advantage of it, but easy to follow. We got good response. And then we brought each and every one of them into our office and the entire team. You saw some photos earlier, I think it was in Steve's presentation, of sitting at the table, talking through, and all of the stakeholders were involved in this. And some people had greater knowledge than others. Some of the conversation was led more by engineering, other by design, some by contractors. We all had our own concerns about what we were about to get into. And that process was awesome. Sitting in a conference room for 2 hours a pop. These interviews were very long. We were bringing people in from all over the country and outside the country. Doesn't sound exciting, but when you're learning and it's exciting and they're telling you what can be done and what can't be done, and we're sharing design ideas right there at the table. What do you think about this? What do you think about this? What about this concept? And they're offering that opinion real time right there. They leave. We spend another hour just downloading from that experience as a team. We went through that process and then sat around the table and together, even though this was going to be Tellefson's subcontractor, at the end of the day, it's Tellefson's subcontractor. I hold the subcontractor. I got the risk on it. But we all sat around because we all knew we were all in this together as the team. And we shared pros and cons of each individual fabricator. And we came to a pretty clear consensus pretty quick. And everybody had something different they were offering that was exciting, but we got there. And together we made the decision. And that started the process of collaboration, which is one of the things that I think has made this project a success. And I think it's the most important thing for any other project going forward. I call this the rest of the story. So you got to feel for that timeline from does this make sense to get it going, to get the board approval, to get everybody on board. We've got our mass timber guy on board. Right behind that, then, here comes this demolition contract. Let me go back one. How do I go back, Justin? Do you know? Bottom button. Yeah, I skipped away. So we've got, I got ahead of myself. So we've got the mass timber contractor on board. And right after that, so this is November, December, an SD set of documents. That gets you an idea of how fast Kirks and the design team were moving through this process. The decision-making was there, great leadership from the college. And we get this SD package in January and we send it out to the market. We get our subcontractor community friends to help develop this budget. We use that SD set to then bring on, because the awareness through all of this process thus far was that we really needed our MEPF team on board to start the BIM process, to start the design assist. Let's try to prefabricate as much as we can. Let's coordinate this thing so in our fabrication of our wood products that we can get as much into that as we want to. So right at the heels of SD, we got our MEPF team on board, and that was a best value approach. So it's a public solicitation. The community was ranked on team, experience, performance with the college in the past, and heavily weighted, of course, in budget opinion on the price of that. So we get them on board, we set a budget, and we go forward. And right behind that, Chuck says, hey, the demo contract is coming y'all's way. Let's get this building out of here. So we had our MEP partners on board in March. We are awarding a demo contract. We start the demo process, and then the following month in April, Kirksey already has a DD set of drawings out. And this is a good set of DD documents. So it's kind of a, and you'll see kind of one of the lessons learned. I call it a foul ball here in a little bit, but the timetable for our delivery got a little twisted. Chuck noted the need. We had programming. We couldn't tear a building down on campus until we shifted programming around. Then that building could drive construction. Well, the time frame of us being able to start, we had to then fragment this design. The original intent was not to do a phased permit delivery process. We ended up doing a phased permit delivery process, which put a lot of burden on the design team, which meant the level of completeness of the design documents was required earlier. So at an SD set, we're looking in a lot of cases of like DD kind of material. We would harvest that material as a team. What do you really need to make decisions? What do we really need to firm up pricing? And it wasn't like we needed a full DD set, but we needed information. So we would send out a little outline of what we needed, and the design team would send it back. And that enabled this process to allow us to keep going, procuring, and getting on, getting everybody on board. With the DD set, we took the next step of, we recognized with our glass, we have Sage glass that requires some coordination. For those of you that don't know what that is, it's a glass that shades itself electronically. So depending on the sun and what's happening out in the environment, it'll shade or lighten the glass. Really cool stuff. It's modeled. It provides a payback to the college over time. This is, I think, our third or fourth project here to do it on. But there's a lot of coordination that needs to happen there with the electrical contractor, within the architecture. So we recognized we needed to bring them on board. And then we also wanted to bring our framer. This is our drywall subcontractor on board. We saw opportunity around the building. Mass timber projects, just because of the desire to detail, it promotes greater awareness of BIM coordination. For us at Telebson, I mean, all of our projects are BIM coordinated. That's just the way we do it these days. No matter how small, how big, we just coordinate them. Saves time in the field, the rework. So for us, it's natural, but it promotes folks that maybe aren't so much into that process to start thinking, because the rest of the team is thinking along that line of planning and what can we get done ahead of time. And the fabrication of mass timber kind of lends itself to that. So with the drywall side, it led to that conversation. How do we get them on board? We were wrestling with some exterior details of, Justin showed some of the conditions of, the relief angles and the framing, and how are we going to do that? So we put out another little package. Again, the level of documents that we were getting from the design team enabled us to put out a package to the market in a competitive bid process and actually solicit bids for glass and drywall at a very early stage. Home run, we get them on board. Now they start working with the design team. We start talking about what we can and can't do. Just the lateral deflection of some things, how we're going to support curtain wall. We're going to go floor to ceiling. Can we take it up in the drywall studs? All of those things, we had big paybacks with that. So very fast process. You can see we're moving. And it was just like the bullet train there. It was a wild ride. What's all the fuss about? So when we got involved in this, like everyone, we went and we attended any conference we could. We looked at anything on the web we could. We talked to contractors. Anybody who had experience, we would listen to. And these were some of the concerns that we were hearing about. This is like a big slide of risk for a general contractor who's about to put $30 million out there at risk. These things worry us. What could go wrong here? We haven't done this before. Oh my goodness, we better pay attention. One of them was protecting the wood. What are we going to do? We've got wood out there. Um, these are construction workers. Things get banged up. Walls are always getting dented. Things, it just happens on the job site. Big concern of ours. Then weather. You think, wow, we've got weather. It's going to rain. We're in Houston. What are we going to do with the wood? Some of the feedback that we've been hearing on weather was, oh, you have to protect these decks, protect them at all costs, tape the joints. You don't want it to rain. The rain will come down through the structure. Everything will be awful. Protect it. So we were going down that line of we're going to protect it. We're going to protect it. We'll tape the joints, squeegee off the decks immediately. Wow, this is going to be really painful. We get into a rainy season. What's going to happen? Opposite, none of that. Yes, we were prepared to do all of that. We were prepared to tend to these slabs as though they were young infants. We were going to tape the joints, and we were just going to do all of this stuff. And we did. We taped the first deck of the joint, and we've got our first rain. And we really didn't like the result. We kind of lost a drainage path. And we called Nordic and said, hey, what do you think about this? And he said, man, I told you guys not to tape the joints. But yeah, we were hearing from everywhere else, it's a good idea. Well, we didn't think it was a good idea. In fact, we prefer that the CLT breathe and just, let it go in. Great. So we stopped it. Yes, right move for Tellefson. Next project, we will not be taping CLT joints. We're going to let them breathe. And that's it. That's a lot of money, a lot of time to do something that the input we were getting from the market differed from our real life experience. Now, different people have different experiences, but for us, we won't be doing it again. And we see that it is draining better and water is a factor, but you can easily wipe a column down. You'll see some examples as you tour the job. Some columns are stained a little bit, and tomorrow they won't be. It's as simple as taking some 220 grit or greater. I'm not even sure what David's using out there, but if we see some staining, we just mildly hit the columns. We've had some in certain conditions, depending on the location. Maybe it's a corner condition where it's just a natural collection of rainfall and it just wants to drip in this one spot. We've had some columns that look just completely, oh my gosh, what are we going to do with this column? And at that point, our timber framers just don't worry about it. Don't worry about it. And we just kept, hey, we need to make sure that column's okay. They went over there and they sanded it off and put we've got sealer that comes from the factory with the sealer, but we've got it on site. We just sanded it off and sealed it up and it goes away. So it really hasn't been a big deal. So I would love to hear anybody, if you ever hear that as a concern from an owner or a project, I'd welcome the dialogue with them. Physical abuse, that was a real one for me. How are we going to keep people from drawing on columns? You go to a job site, you see doodling everywhere. You see man lifts crashing into walls. It's like driving on 610 at 5 o'clock. These guys driving these man lifts around the job site. They back into this and back into that. It happens. And then the erection process. What are we going to do? Well, it didn't take too long that just getting some beams and columns off the truck and the first ones we had set in place, we had some edge conditions that were really rough and it was alarming. It's kind of like what Steve said. You look at the wood and you start hitting the panic button. Oh, what are we going to do? What are we going to do? And we go to our erector who travels with various fabricators and does mass timber erection. And they were just like, don't worry about it. We'll take care of that later. Oh, no, you got to show us you can fix it. No, we can fix it. Don't worry about it. Okay, we'll wait. Hey, you got to fix it. And they go and they fix one. They entertain us. And it's a quick and easy fix. They can actually just cut out a lamella and replace it. And they sand it off. You don't even know it's there. You can walk around the job site and you can't pick these things out. So that was a great relief early that, okay, we're seeing damage, this is done, but I'd never heard about that. Nobody talked about it in any of the information we talked about, that the normal job site stuff will happen and it can be fixed. So I just was always afraid of it and I had that risk. I don't have it anymore. Site logistics, deliveries and laydown. There's a lot of timber. There's a lot of CLT panels. What are we going to do? You're bringing all of this stuff in, maybe from a different part of the country or another country. It's going to hit the job site. You can't just bring it from the local warehouse or somebody's steel fabrication yard that's right here in Houston. And, oh man, what are we going to do? Well, we solved that problem in our interview process, talking to all of the different fabricators, some from overseas. How are we going to do it? Well, we're in a great location. We have rail, we have docks, you name it. Ended up not being a problem at all. So our material came from Canada and it was railed down. We had a very detailed schedule of production and fabrication the team abided by. We got it here to Houston. It went over to a local rail yard. The rail yard provides you something like 30 days of free parking, if you will. I'm sure it's in the rate somewhere. But all of our material was here. When you say just in time, I'll say just in time, but a month early. We were concerned about what happens if the rail keeps running or stops running, the snow, all of these things. Your mind can just get carried away when you're doing something new, right? Anytime you're doing something new, it can be a little scary. It went perfect. They had this package so well detailed. The logistics, it's what they do day in, day out. It arrived on time. It was staged, and it literally was brought over here. It was just in time, but just in time from a dock not too far away. And we'd bring out a trailer. They would load the material on the site. Our site was never congested. We got to a point where we just said, hey, we've got some more room, bring some stuff out if you want, and it wasn't because they needed to, it was because, okay, if you want us to, that's great. And we have an opportunity to get ahead doing some connections or something, we'll do them. Not concerned about that. Penetrations. Okay, 10 o'clock. I can talk all day or I can go faster. The need and the timing. The guys showed that we, in our coordination, and we have a very strong subcontractor team, and working with Nordic, we made the conscious decision. You hear everybody, oh, you have to have everything done, coordinate everything, no field penetrations, nothing like that. We talked to our erector and said, hey, if we wanted to core some holes in the field, because it's not a normal drill bit, is it a big deal? He said, no, but don't do anything big, do small. So he gave us a matrix, and it was a shopping list of, do you want a 2-inch hole, a 1-inch hole, a 3-inch hole? This one's $60. This one's $80. If you want one that big, it's $100. And we had it. So during the BIM coordination process, like the lighting alignment, our team said, hey, we recognize there are construction tolerances. And when you have a long corridor along a line like that, how are we going to keep it straight? So we elected to drill some in the field. Right decision. Don't let somebody steer you into, and I have a project some subcontractor friends are involved in right now. And the mandate is have everything cored at the fabricator, and lessons learned is have cored what makes sense. Higher MEPF cost. I'm gonna go over the detailing. I'm curious about time. I mean, I can keep going. Should I keep going? Yeah. Okay. I'll keep going then. The higher MEPF cost, there was, feel free. I mean, if you want to get up and break, you're not going to hurt my feelings. I think from the market being something new, you might have gotten that a little bit from the market initially that, hey, what is this? What are we going to get into and the pricing? But I did get some feedback from some of our team members that said, no, we didn't approach it like that. We weren't scared of the wood monster. And I think definitely our team that's been involved to date, no. And they may have advantage in the future in a competitive bid situation because of their experience and seeing, okay, so they might have spent a little bit more money here, but they saved a lot of money here. I think overall, we've got a more efficient process going on in the field. It's probably going to give them a competitive edge in the future, would be my guess. Long-term flexibility. There's been debates on, you've got this wood structure. How can you retrofit it? I've read those articles. I don't understand them. I think when you look at our mass timber frame, we've got this one-way structure. We've got these huge bays. I I just don't understand it, but you'll find articles out there that talk about it. I mean, you can drill, you can modify this structure very easily. You've got all the open space, more open space than you would in a steel building. So I dismissed that one. Material transportation costs, it's real. So it's a big number. Mr. Smith harvested that number for our project. It is a big number and it's a cost driver, but everybody is getting more competitive and I only see that coming down. When we start getting local CLT providers in our region, we're going to see that go down, and it's a six-figure number on transportation cost, and transportation costs this past year are up anywhere from 65 to 70% right now from a year ago. So that's pretty crazy. Acoustics and vibration we touched on. It has been a little bit of a problem, not so much vibration. You know, our concrete guys got up there and they jumped around and they said, hey, this is way better than steel. And that's the perception when you're actually working on it. Acoustics, I think, you know, I'm a naysayer right now. I think that technically, when you do the math on, you know, sound transmission, I think we have the right solution to meet a pretty stringent specification. But I think in hindsight, we would all spend a lot of more time. We'd like to run an experiment on acoustics to see, do we really need what we have out there right now? Home runs, the team, great team. The college, the design team, we've all worked together for a long time. And it took collaboration here. You saw the bullet train, you saw the craziness of immediately shifting to a non-traditional project delivery approach on a new subject matter in our region. Couldn't ask for a better team. Mass timber fabricator, Nordic's great. We made the right decision. Working with some other guys and some other stuff right now, but we made the right decision for this project. Really appreciate them. BIM coordination, again, very important. Make sure that when your team, you're selecting your team, it was a high criteria for us in getting our MEPF team on board. And they're a high powered team. So putting models together and making sure files are right. And when you're moving like a bullet train, file management is very important. You may be working on a file that is 2 hours old. I mean, everybody's just moving really quick. So everybody having that knowledge and how to work in that environment, very important. We did it well. Safety, I've got to say this about safety. This has been the most incredible erection process I've ever been involved in. I've been doing this 20 something years now. It was painful, and it was painful because we bought our schedule as though we compared it to a structural steel. So people say, maybe you can go faster, maybe you can do this. Well, yes, but we're building a schedule. Let's build a schedule. It meets the college's need. And it was kind of more of a traditional steel kind of duration. Great. Yes, we're hitting right along on schedule, very comparable from a schedule to a steel building. What's not comparable is we had 5 guys, 5, maybe 6 every now and then. That's it. So when you saw those photos of the flyby and you saw the 2 guys up there and the 1 guy, and there's another guy over there in the crane, that's the entire erection crew on this job. It was painful to watch because you wanted craziness. When you have a steel building going on, there was going to be 12 or 15 guys out there banging, sparks flying, crane swinging, materials getting dumped, lulls everywhere. And that wasn't existing. So you'd walk out to the job site and it was like watching paint dry. You would sit there and just, you know, there goes another beam. There goes another beam. But at the end of the week, the amount of square footage that got put in place was equivalent. So you're doing the exact amount of work with 3 times less people. And we think without a doubt, if we could have go back in time, put another little crane over there, a little crawler type crane, we could have probably could have shaved 20 to 25% off the erection schedule alone. Kind of equivalent, probably with less men too, probably just adding another crew on board. Awesome. That plays into the noise pollution too, then the CLT. All right, we're going to wrap it up. The CLT elevator shaft, it's a home run. You're going to see it over there. A lot of debate. Elevator folks bought into it. Not everybody bought into it, but they will buy into it. Ours did. Steel towers. We love the way the outside is. Alignment of design, construction, procurement schedules, we talked about. We were on a different track to get going. If we could do it again and plan that way, probably would have been more efficient. Then a replay, acoustical treatment, or deck pour sequencing. We had some finesse going on in the slabs that caused us to do more pours. We would like to have done bigger pours, and then the exterior detail. So I must talk too slow. So I had some other stuff, but we're going to wrap it up. There's some case studies here that, we can talk about. Find me. I'm going to go to this one right here. You'll note that we prefabricated exterior wall panels on that site. Home run. Home run. So take a look at them. If we could do it again, we would consider changing our exterior detail here to the one on the right that I've blue beamed up. And we would have liked to have seen that third floor relief angle be owned by the cold form framing designer easily. We only have one floor. So this would be an application in a smaller floor where masonry could be gravity loaded for the first two floors, supported off the cold form for the third floor, bypass that slab completely. And man, we could have built the entire exterior of this building in Baker Drywall shop. And we probably could have enveloped this building in hindsight in a week. So when you go out there and look at the building and look at the vertical panels, think in your head, could this thing really been wrapped in a week? Superintendent says, I could wrap this in a week with this team, with these panels. So think about that in your future designs. Again, it goes to the innovation of mass timber. Everybody has to be thinking modular design, something we'll talk about later. Okay, that's it. I'll wrap it up. Thank you, everybody.